So once again, welcome to the review lessons for Shaughnessy's class. This is Rational Expressions Lesson 10. Standard disclaimer, please make sure you're attending class. So up until now in this unit we've been talking about rational expressions, what they are, reducing them, non-permissible values, multiply, divide, add and subtract, and last class we were talking about solving a rational equation, and we did it using what I tend to call the mystical magical method. There are other ways. Here's another one that I want to go through. Okay, MTVs. So you can tell I need to get into the habit of reading these because I just dictate them to Siri and then I haven't read them. So long story short, this is another method. Find the lowest common denominator and state all the NPVs. Same first step. Once I find the lowest common denominator though, step 2 is a little different. Step 2 in this method is multiply the numerators of all the terms on both sides of the equation by the lowest common denominator. Keep in mind that the multiplication is only affecting the numerators. You're allowed to do this because if you do the same thing on each side of the equals, whatever you do to one side, you have to do to the other. Now what ends up happening is if you use the lowest common denominator, multiply both sides, you will notice that all of the denominators cancel out. So this is like your mystical magical. The denominators disappear. And we're kind of doing that with mystical magical anyway. That's what's going on here. Once all the denominators are gone, I solve what's left and I check it against the NPVs. So stealing a couple quick examples similar to the ones you had yesterday, e.g. 3 over x minus 2 equals 5 over 2x plus 1. Okay, I look at this. First thing I do is I look for my non-permissible or my lowest common denominator. There's an x minus 2. There's a 2x plus 1. Neither of those can be factored, so I'm going to use them both in my answer. Okay, looking at my NPVs. I'm going to get x minus 2 cannot equal 0, so x cannot be 2. And I'm going to get 2x plus 1 cannot equal 0. Whoops. So I'm going to get 2x cannot equal negative 1. So x cannot equal negative 1/2. So there are my non-permissible values. Okay. Looking through a variety of different options, now I multiply both sides, numerators only, by my non-permissible values. X minus 2, 2x plus 1 to that numerator. X minus 2, 2x plus 1 to that numerator. When I do, and I'm going to rewrite it, okay, you don't absolutely have to. I'm going to get 3 times x minus 2 times 2x plus 1 all over the x minus 2. There's my equals. 5 times x minus 2 times 2x plus 1 all over the 2x plus 1. And what I will notice is here the denominators cancel with that x minus 2. Here the denominators cancel with that 2x plus 1. So I'm left with 3 times 2x plus 1 equals 5 times x minus 2. It's not magical now where the denominator went, it cancelled out. So now I just solve what's left. I'm going to get the 3 goes through, 6x plus 3 equals here, I'm going to get 5x minus 10. Subtract the 5x over to one side, subtract the 3. Whatever I do to one side, I have to do to the other. There the 5x's go. On the left, the 3's go. 6x minus 5x is 1x. Negative 10 minus 3 is negative 13. Just like before, I check them against my NPVs. They're not NPVs, so all is said and done, it's nice and clean. Okay. If I look at more examples of these, it's the same basic idea all the way through. Now, I prefer this method. Truly, if I'm working on my own, I prefer this method. Why did I teach you the other method first? Honestly, because that way it kind of links to what you were doing with adding fractions. Because with adding fractions, you don't have a choice. But with the solving, you do. And if I start teaching the solving too quickly, with a shortcut way, people tend to get them confused. So if I look at x minus 5, correction, x minus 5 over 1 minus x equals 3 minus x over x minus 1. I look at this, okay. You can notice that these are going to cancel somehow. Whoops. These are going to cancel somehow, but I'm not going to worry about it. First thing I'm going to do is find my lowest common denominator. The nice part with this method is it always ends up working. So I get 1 minus x, and I get an x minus 1. And my non-permissible values. I get 1 minus x cannot be 0. So 1 cannot equal x, so there's one of my non-permissible values. On the other one, I do get x minus 1 cannot equal 0, which tells me x cannot equal 1. They are the same, so I don't have to worry about that. Now what I do here is I multiply by my common denominator, so I have x minus 5. I'm going to go a 1 minus x and an x minus 1. Even if you don't notice that, 1 minus x and x minus 1, these are all said and done. Here the 1 minus x's cancel. I don't usually rewrite, I just cross out here. And here the x minus 1's cancel. So what I'm left with is the x minus 5 times the x minus 1 equaling the 3 minus x times the 1 minus x. So I'm going to multiply these out. Now once again, as I've been saying all along, if you don't know what's going on with these multiplications, please let me know. I'm going to get up with x squared minus 5x minus 1x plus 5. On this side I'm going to end up with 3 minus 3x minus 1x plus x squared. Okay, cleaning that up, I'm going to get x squared minus 6x plus 5. And on this side I'm going to get x squared minus 4x plus 3. Picking one of the sides, you got to pick one of the sides. I'm going to put it all on the right this time. So I'm going to subtract the x squared, add the 6x, subtract the 5. What I'm going to end up with is 0 on the left. X squared minus x squared is gone. Keep in mind quadratics. I know how to solve a quadratic. Okay. Negative 4x plus 6x is 2x. Negative 3 minus 5 is negative 2. Solving that out, move the 2 over. I'm going to get 2 equals 2x. Divide by 2, I'm going to get x equals 1. Check against my non-permissible value. Wait, that's not allowed. So this is rejected. It is an extraneous solution. And what I'm getting is there are no solutions. Okay, so that's how to do it another way. Truly, whichever method you prefer works. You don't have to know both. However, you should be able to recognize what's going on with both, because like on a diploma exam, multiple choice, they're going to ask you where did Johnny make his first error, and you need to make sure that you know where the error is. So going with that. So that's solving rational expression or rational equations another way. Now, along with that comes where we go next. Now next, and I know this, we're building an equation. We're trying to solve problems. That's the focus of this whole unit, is being able to solve a problem with this. So there are a bunch of things that you have to know. Okay? And if I were you, I'd pause and read these. But the biggest one I want to talk about is this. Distance equals speed times time. Or if you're a physics guy, velocity times time, and it's displacement, and I get it. However, for Math 30-2, we don't worry about that too much. Speed equals distance over time. So you just divide by time. Okay? Or you could divide by speed and get time equals distance over speed. Okay? So you've got that idea. Now, it may seem random, and that's what this next sentence says, but you need to be able to recall these sorts of things in order to do questions. Also, too, if it's bigger, 5 larger, it's x plus 5. If it's 5 smaller, it's x minus 5. If it's 3 times one number equals 2 times the next. 3 times larger than twice the amount of x. This is 3 larger than twice the amount of x. Okay, so on and so forth. If 3w and 5z are the same, then 3w equals 5z. Little ideas that go along with this. So if I look at this example here, and I'm just trying to make sure that the focus is here. A lot of these word problems best to do in a table. So if I look here, Sally and John took turns to drive a total of 300 kilometers. Okay? So a total of 300 kilometers. Okay? So I know that my cases, I'm just going to go on here, Sally and John. And the total, the total is 300 kilometers. So this distance plus that distance, 300 kilometers. Sally drove 80 kilometers per hour. So I know Sally's speed, 80 kilometers per hour. It was 10 faster than John. So if 80 is 10 faster than John, how fast did John go? Okay, it doesn't say, but you know. If 80 is 10 faster than John, John must have gone 70. Okay. I'm looking at this because I think there's a flaw in this question. Sally and John took turns to drive a total of 300 kilometers. So this is x. Nope, never mind. Because I don't know how far Sally went. So I look at x, I say I don't know how far Sally went. John drove 300 minus x. Whatever the difference was. 300 minus however far Sally drove is how far John drove. Now using what I remember from here, and I'm deliberately circling it, time is distance over speed. Okay, here the time is the distance, x, over the speed, 80. Okay, and here this one is the distance, x, or 300 minus x, over the speed, 70. Okay, so I've got my distance, my speed, my time. Find an expression for the time of both drivers. Now, we need to end up giving you a little bit more information. If they both took the same time. So that's the extra information. I'm sorry about that. That wasn't necessarily in here. It was just an error in the dictation, I think. If they both took the same time. So I need to pick the x, 300 minus x. If these two times are the same, then my equation is x over 80 equals 300 minus x over 70. And what I end up getting there is my equation. Now I can solve for how far Sally drove. Once I have x, I can figure out how fast John drove. Once I have that, I can figure out the different times. Okay? But the key is I've got to find a spot to put the x in. Now, this third one here, and we'll do some more examples. This will hopefully make more sense later. What do I know about what x can be? Okay? Well, I know x has to be greater than 0. Why do I know that? X is a distance. You can't drive a negative distance. Okay, so it has to be greater than 0, and it also has to be smaller than, I can confidently say 300. It has to be smaller than 300, because if they drove 300 kilometers in total, the amount that Sally drove, if they both drove for the same length of time, has to be less than 300. I'm cautious to say I don't want to say it's 150, although it's probably 150, but I can honestly say it's greater than 0 and less than 300, or I could say between 0 and 300. I know x can't be negative. Even if the algebra gives me a negative x, I know that that doesn't make any sense because I'm talking about something. If x is the distance Sally drove, Sally can't drive a negative distance. Okay, so you're trying to set up tables. These tables are often really helpful. The idea is you just got to get comfortable doing it. So today's homework is going to be largely on doing this. If I look at this one, a plane can fly at a certain speed in still air. The wind at its back, it traveled 30 kilometers per hour faster. The wind at its front, it travels 30 kilometers per hour slower. A 500-kilometer trip took 1 hour longer to travel into the wind compared with having the wind at its back. So with the wind at its front and the wind at its back. Okay, and I just got to pick. Now, okay, 500-kilometer trip. The distance in each case is 500 kilometers. In each case, I went 500 kilometers. If the wind is at my front, I'm going 30 slower than I can do. If the wind is at my back, I'm going 30 faster than I can do. Stop that. Take a look at that. What do I know? I know x is the speed in still air. Because if the wind's at my front, it's slowing me. The wind is slowing me down. If the wind's at my back, the wind is speeding me up. X is the speed in still air. So I look at these. A. Find an expression for the time in both situations. Well, I know that time is distance over speed. That's what it told me in the last one. So time is the distance, 500, over the speed, x minus 30. In this case, the time is the distance, 500, over the speed, x plus 30. So I've done A. Which of the times is larger? So now I need to stop and think, well, which time is larger? Which means which one took longer? If the wind is at my front or the wind is at my back? And you stop and think about that. If I'm going slower, it's going to take longer. So I'm going slower with the wind at my front, so this time is bigger. So which of the time is larger? When the wind is at the front. Why? Because we are traveling slower. Okay? The wind at the front, if the wind's blowing against me, I'm traveling slower. So I've got that. Set up an equation. Okay? So the equation, what do I know? Well, I know this is the bigger time. I know this is the bigger time. I cannot emphasize that enough. This causes confusion. If this is the bigger time minus the smaller time will give you how far apart they are. The bigger time minus the smaller time gives me how far apart they are. It tells me that here, 1 hour. There's my equation. The bigger time minus the smaller time tells me how far apart they are, and they are 1 hour apart. So that much I'm done. What do I know about what x can be? Well, x is the speed in still air. If one of the speeds is 30 smaller than x, I know x must be greater than 30. It can't be less than 30, and there's going to be a maximum. X has to be less than 1 billion too, but nonetheless I'm absolutely certain that x has to be greater than 30, because if x is less than 30, then this speed doesn't make any sense. And if this speed doesn't make any sense, this problem doesn't make any sense. So for this problem to work, x has to be bigger than 30. It doesn't matter here, because I'm just going to add 30. If x is bigger than 30, add another 30, it's still all good. But here, in the x minus 30, I can't subtract the extra 30. Long story short, this is just kind of the idea of what's going on. Please go back and rewatch that if you need to. I'm going to continue on. A trip to the cottage consists of 150 kilometers on paved road and 60 on a gravel road. The speed on the paved road is x. The speed on the gravel road is 25 slower than the paved road. The trip took 2.5 hours. This gives us the following information. Well, what I know is I've got a paved road and I've got a gravel road. Okay, 150 on the paved, 60 on the gravel. The speed on the paved road is x. The speed on the gravel road is x minus 25. The total time is 2.5. So this time plus this time has to be 2.5. These two times add up to 2.5. They're not each 2.5. The trip took a total of 2.5 hours. So I know that these two times added together will give me that. Find an expression for the time. Well, keeping in mind I know time is distance over speed, this time is going to be the distance, 150, over the speed, x. This time is going to be the distance, 60, over the speed, x minus 25. I know that these two times, when added together, give me 2.5 hours. So the A is done. What do we know about the times? We know that the times add up to 2.5 hours. Okay, I know that the times add up to 2.5 hours because it tells me that the trip took a total of 2.5 hours. Total. Total means essentially add. So I know that these add up to 200 or 2.5. Find an equation that models the situation. 150 over x plus 60 over x minus 25. Because I know that these two times add up to 2.5, I can create this equation. What are the domain and range of the domain of the permissible values? Well, x is the speed on the paved road. I know it has to be bigger than at least 25 because if it isn't bigger than 25, I can't subtract 25 and still make it make sense. So I know x must be greater than 25. Has to be at least 26 or 25.001. Okay, it has to be that. Now, realistically, it's probably much larger than 26 or 25.001, but nonetheless, I am absolutely 100% certain that for this to work, x has to be greater than 25. So taking a look at another example. Philip burns 70 calories per hour cycling and 90 calories per hour jogging. He cycles for X hours and jogs for 1 hour less. Okay, get rid of that or. He jogs for 1 hour less. This gives us the following table. Well, I've got cycling and I've got jogging. Okay. I burn 70 calories per hour cycling. So that's the speed of the burn. 70 calories per hour. Okay. 90 calories per hour jogging. The time. I cycle for X hours. I jog for 1 hour less. So this is going to be X minus 1. Okay. If I burn 70 calories per hour in X hours and 90 calories per hour for X minus 1 hours, find the expressions for the total calories burned. So I need to figure out these. Well, if I burn, as I was saying before, 70 calories per hour, and I do that for X hours, I'm going to burn 70X calories. Okay. If I burn 90 calories per hour for X minus 1 hours, I'm going to get 90 times X minus 1 calories. You could say this is your distance. How far have you gone? How many calories have you burned? Your speed, how fast you're burning the calories. And the time is time. So distance equals speed times time. I know it doesn't seem like it matches up, and this is probably not even showing up very well. Okay? I know it doesn't seem like distance, speed, time, but that's what this is. So when I'm looking at the expressions for the total calories burned, 70x and 90 over 90 times x minus 1. In total, he burned 850 calories. So this amount of calories plus this amount of calories has to be 850. So 70 amount of calories, 70x, plus the 90 times x minus 1 has to give me the total calories. So I get 850. This doesn't look like a rational expression. It's over 1, so you could kind of make a case for that. But nonetheless, this is the equation that results. C. What do I know about the domain of admissible values of x? Okay, I know x is a time. It has to be positive. You can't have negative time. But better than that, it has to be greater than 1. Okay, because if it isn't greater than 1, I can't say he jogged for 1 hour less. Because if it's like 0.5, subtracting an hour, I'm now doing jogging at negative times, and that doesn't make any sense. So I know x must be greater than 1. Okay? So these are just some examples. What I've got is I've got a series of worksheet here for you to work through that hopefully will make sense. It's essentially doing the same thing over and over and over again, just to make sure you're comfortable building the equation and figuring out the pieces from it. There are a few more examples in class, so hopefully that would be helpful if you were there. Otherwise, just come and ask questions, and have a marvelous day. Bye-bye.